In today's lesson, we'll be using the candidates test to determine absolute extrema. So the idea is we will be looking at functions on closed intervals. So we'll have endpoints that we have to deal with. So the idea is if we have a graph, we have to consider those endpoints to be absolute extrema. So in this case, this would be an absolute max, but then this critical point here would be an absolute min, and then here we have relative min and max. Okay, so first example, we'll have this function, f of x equals x to the third minus 27x plus 2, and we will look at it on the closed interval from 0 to 4. So already I have 2 points to consider. So we're going to have to consider f of 0 and f of 4, the endpoints. So now we have to find the critical points. So we will do what we've been doing. Let's find the derivative, set it equal to 0. So 3x squared minus 27, set it equal to 0. I'm going to factor out a 3. So I have critical points at x equals -3 and x equals 3. So in addition to the endpoints, I need to consider these critical points. But actually, because we are on this closed interval from 0 to 4, we actually don't want -3. It doesn't even fit on the closed interval. So now we're just going to substitute 0, 4, and 3 into the original function. F of 0 equals 2. When you plug in 4, f of 4 equals -42. And then f of 3 equals -52. So it's as simple as, hey, the highest number, this would be an absolute max. And the smallest number, this would be an absolute min. So the graph might look something like, so this endpoint is the highest, and then the critical point here is the lowest, and then it comes back up like that. Okay, next example, function f of x equals 3x to the power of 2/3 minus 2x, and on the closed interval from -1 to 1. So right away, we will have to consider f of -1 and f of 1. But now let's find the critical points. Okay, so derivative of f, if I bring down that power rule, that would be 2x to the -1/3 minus 2. So if I set this equal to 0, I'm going to write that as 2 over the cube root of x minus 2. So remember, critical points happen when the derivative is equal to 0 or when the derivative does not exist. So because I've got the variable in the denominator, we'll have a critical point at x equals 0. And then if I solve this, if I add 2 to the other side, 2 divided by 1 gives me 2. So I already have 1 as an endpoint, so I just need to add f of 0. Okay, so if we plug all of these into the original function, we can find our absolute min and our absolute max. F of -1 equals 5, f of 1 equals 1, and f of 0 equals 0. So here is my absolute max, and this would be my absolute min. Okay, so now for the last example, maybe just pause the video and sketch this graph. So this is a derivative graph. So we have f prime and we want to find the absolute min and max on f of x. So first I'm going to turn this f of x graph, or f prime of x graph, into a sign chart and look at the sign of f prime of x. So I'm going to look at the interval from -3 to -1. And then when it is 0, so this would be a critical point right at -1. And then the next interval from -1 to 2. Okay, so it is positive, 0, and then negative. So it's increasing, 0, and decreasing. But what we're going to do is, if you look here, so that should give you a little visual that that first interval, it is increasing longer than this one would be decreasing. So that means here we're going to have the absolute max on that interval. And then we'll know that this endpoint is an absolute min. So f of x has an absolute max, or absolute min, I'll do first, at x equals, at this endpoint, -3, and an absolute max at its critical point at x equals -1. So there is your full lesson on using the candidates test to determine global extrema. Good luck with your lesson.